Okay, so we're going to do a few hypothesis testing problems just so you can test out what we've learned in our first movie. So follow along with the page that I attached, and we talk about the adult customer of the fast food chain. And what we're going to do is set up our hypothesis. And excuse me. Sorry. And what we're going to do is look at that second to last sentence, carry out the hypothesis test to determine if the mean number of calories consumed is more than 750 calories. Aha, more than. That's one of our secret phrases. So we know we're going to have mu less than or equal to 750 versus mu greater than 750, right? Good. Okay, let's line up what we know. We know that X bar is 857. We know that S, I write script S, is equal to 677. And we know that N is 3857. Okay, so that's definitely greater than 30. So you might be wondering, how can I use the formula that has sigma rather than S for my test statistic? Well, in the case when N is greater than 30, sigma and S are approximately the same, so you don't have to worry about that anymore. Okay, so you can go ahead and plug those values in without any problem. So let's do it. So I'm going to have Z star, that's my test statistic, is 857 minus 750 all over 677 over the square root of 3857. And that's going to be 107 over 10.9009. And when you do all your hand waving, you get something to the effect of 9.815, something like that. Okay, so that's step 2. Then in step 3, this is our greater than. So we know our alpha is 0.01. And we really want 1 minus alpha. So that's going to be 1 minus 0.01 or 0.99. And we're going to look in the middle where the probabilities live for the closest hit to 0.99. And we will see Z of positive 2.3 from the left, 0.03 from the top. So that gives me 2.33. So that gives me my setup for my if-then. So my if-then statement is going to be if Z star is greater than 2.33, then we reject HO. Okay, so we think about it for a minute. Our Z star was 9.815. Is that greater than 2.33? You bet. So we're going to, in step 4, reject HO. So in the context of the problem, they are consuming much more than the 750 calories. Okay, good. Let's take a look at our second problem. So in this one, we go down to the second and the last statement, and we look to see, test the claim that the mean amount is less than $10. Okay, less than, aha, we know how to do that. So that's going to be mu greater than or equal to 10 versus mu less than 10. Yay. That's step 1. Okay, because it came right out than. Then in step 2, what do we know? X bar is 9.15. Script S, which is standard deviation, is 7.6. And N is 2000. So when we put our Z star together, we have 9.15 minus 10 over 7.60 all over the square root of 2000. And that's going to give me minus 0.85 in the roof over positive, my fault, 0.16994 in the basement, and it's going to settle down to minus 5.0017, something like that. I went decimal happy. Okay, so that's our test statistic, minus 5, actually just very close to minus 5 itself. All right, so we have to set up our rejection region. And on this one, when you have the less than, you just look up alpha as it stands. And here again, the closest hit is actually going to be at 0.0099. Not surprisingly, it gives you a Z of minus 2.33. So your if then is going to be if Z star is less than minus 2.33, then we reject HO. All right, so we think about our test statistic, our minus 5. Is minus 5 less than minus 2.33? And if you forget, draw your picture, because sometimes negatives get a little funky. So here's 0. Here's minus 2.33. Here's minus 5. Okay? So, even another way to think about it, if the test statistic falls in the shaded in piece, you're going to reject. Okay? So what are we going to do? Of course, we will reject HO. And the amount is considerably less than $10, again, in the context of the problem. Okay? All right. Problem 3. Now I did something sneaky on this one. Go to the last sentence. Determine if sufficient evidence exists that states that the mean differs from 12.5 hours. Differs from, aha. That's not the sneaky part. You're happy because we know differs is one of our secret words. But there's no alpha there. When there's no alpha in a hypothesis test, it's implied that alpha is equal to 0.05. That's just a statistical convention, not like where I go, not that kind of convention, a tradition, okay? So if it doesn't say explicitly, use alpha equal to 0.05. Okay, so let's put this there. So step 2, what do we know? What's X bar? X bar is 12.7. S is 5. Okay? And N is 1,000, referring to the 1,000 internet users. So we're going to have 12.7 minus 12.5 all over 5 over the square root of 1,000. and that's 0.2 over 0.15811, better known as something like 1.265. Okay? Did everybody get that? Good, I'm pretending that you're answering me. All right. So let's think about step 3. We know now that alpha is equal to 0.5. We know since this is an equals not equals, we need to get 1 minus alpha over 2. So we get alpha over 2 first. That's going to be 0.05 over 2, or 0.025. Running out of space. So 1 minus 0.025 is 0.9750. And when you look in the middle of your tables, and actually we saw this in the other movie, there's an exact hit at 9750. It's attached to 1.96. Okay? And then we will also use minus 1.96 for the opposite. So my compound if then is going to be if z star is greater than 1.96 or z star is less than negative 1.96, then we reject HO. Okay? Now this one you have to think a little bit about, and I'm going to draw the picture in a second when you get caught up. Okay, picture. So here's 1.96. There's the shaded in piece. Here's 0. Here's minus 1.996. And here's 1.265. Okay. So, if z star is greater than 1.96, is it greater than 1.96? No. Is it less than negative 1.96? No. So we're going to reject HO. And again, another way to think of it, if it's in the shaded region, you reject. If it's in the unshaded, you fail to reject. Okay? And that's true no matter what the case is. So it's failed to reject HO. So the mean is not significantly different from 12.5. Okay? Significantly different. Because your first inclination is to look at this and say, well, the sample mean was 12.7. I'm comparing that to 12.5. They're not the same. But they are not significantly different from each other. There's a difference. Okay? Great. Thanks.